Hello and welcome to a question on a ladder problem from the textbook. By the look of it, I think it's question 4. I'm guessing that Izzy, you were looking at question 4, but I think it was question 4. Is this the right one? Yeah. Question 4, uniform ladder of mass 20 kilograms, length 8 meters. I'm guessing it's this one. It just looked like more of a I don't know, maybe it was question 3 though you wanted. I really don't know. I'll do this one and maybe I'll do the other one if you get back to me, but I was just waiting for your email back. Okay, so hang on, let me just have a look at. Maybe I should stop this. Is it question 3 or question 4? I just don't know. I just don't know. I really don't know. Okay, well, I'll try this one. So, a ladder of mass 20 kilos, uniform as well, so it'll be acting in the middle of the weight. Might as well put that on straight away. These start looking all the same after a while. The ladder problems particularly, I think I probably like them most. Okay, we know the angle because tan theta is 2, and so whatever inverse tan of 2 is, I don't actually know off the top of my head. I don't know, 60 something is it? Let's have a look. Inverse tan of 2. 63.4, yeah, so we know that angle, but obviously we just keep calling it tan theta equals 2. Obviously you can even, and you're well, served to do something like that, so you know that sine theta is 2 over root 5 and cos theta is 1 over root 5, yeah? It's all in the prep work, these questions, by which I mean take your time earning no marks and you'll probably get all 8 if you draw a really nice diagram. Now it's against a smooth wall, and as it's a wall, the reaction force here is going to be like that, and as it's smooth, there's no smooth wall. There's no other force at, we often call this bit A and this bit B, so I'm going to stick with tradition and do that. Okay, what we're going to have here, so I can call this RB now, because that's the reaction at B, and I'm going to call this reaction RA. They're not the same thing. You're going to have a friction here because the ground is rough, and as the buoy climbs, it wants to slip in that direction, so friction is going to oppose that, so I'll call that F. Now, how high up is the buoy? I honestly don't know. I'm going to call it X. So we'll put X on there. So this is the buoy, and he's a mass, what's the buoy of mass? 30. Yes, we've got a 30G acting down here. Try not to have your diagram too crowded. Mine is starting to feel a little crowded, to be honest. I might move that 20G just so it's obvious, because remember, these are hypotenuse values, and that's why you end up doing 20G cos theta and 20G sine theta for that, just like we're going to do 30G cos theta, 30G sine theta for that. Okay, and that's length 4, and that from there to the midpoint, which will dot like that, that is also length 4. Just remember that. That might be the easiest way of doing it. Okay, I'm now ready to start. I've got the boy climbing up the ladder and everything else. Okay, in these questions, you always have to take moments at A and then do lefties equal righties, uppies equal downies. And you can do those in any order, especially when it's worth 8 marks. Let's do lefts equal rights. RB is going to equal F. Let's do ups equal downs. 30G plus 20G equals RA, so that makes 50G equal RA. In the exam, I'd probably write 30G plus 20G, even though it's obvious, but I do wonder sometimes, like, are they going to steal a mark off me because I haven't written enough down? Okay, so that's equating forces left in the left and right and up and down direction. It's resolving forces, that's what it is, and it's because it's in equilibrium. We could assume it's on the cusp of being in equilibrium here. In other words, it's in limiting equilibrium, yeah? So if it's in limiting equilibrium, this is actually an F max, yeah? The friction will be at a maximum when it's in limiting equilibrium. Remember, F max is mu r, so I'm going to write down on this side, F max is 0.3 RA, because I think F max is 0.3, yeah? And I think we're good to go now. Okay, let's do the nasty bit, which is always taking moments. 99% of the time, it's best to take moments here because you're knocking out 2 forces. If the ground was smooth and the rule was rough, I'd be taking it up here because I'd be knocking out 2 forces up here. But you can take it anywhere, actually. But I find it easy to take it down here. Okay. These 2 forces are going to turn it in that direction, whereas this force is going to turn it in that direction. And you can establish that by holding your ruler here and pushing in that direction your ruler, it will turn over there, and then pushing down on your ruler, it will turn in a clockwise direction with these 2. And so, knowing that, I'm going to need to do x times 30g cos theta. Yeah, and that's just because you need to always do distance times by perpendicular component of force plus 4 times by 20g cos theta. And that should be equal to 8 times by, okay, now this isn't completely perpendicular to the direction of the ladder, and so what I'm going to need to do, as that's theta, that means that is theta, which means that's 90 minus theta, which means this angle here is theta, yeah? And let's write RB where it belongs on the hypotenuse, just to remind us that RB is a hypotenuse value. And so what we need to do is make it equal to 8 RB sine theta. Now make sure you understand all of that and exactly what I'm doing, because that's the critical step, and it's probably where you went wrong if you did go wrong. Okay, what have we got here? Let's plug some stuff in. Cos theta is 1 over root 5, sine theta is 2 over root 5. If we times everything in this by root 5 though, straight away, well, okay, I won't do that. Okay, I'll write down 30gx over root 5 plus 80g over root 5 equals 8rb times 2 over root 5. But I can, of course, times that all by root 5. And I'm going to get 30gx plus 80g equals 16rb. Now let's just remind ourselves what we're trying to find here. We're trying to find the value of x. Yeah, that's basically the whole question. Well, how can we link RB? Well, RB is F max and F max is 0.3 RA, and I know RA. Yeah, so it's a little like detective bit, this bit, where you're like, but if you get those 3 things right, you'll get most of the marks. 5 of those 8 marks will be for doing that, and the moment equation. Okay, F max is 0.3 times by 50g, which sounds to me like 15g. And so here, as F max is RB, I can now say that 30gx plus 80g equals 16 times 15g. I think 16 times 15 is 240. So that's going to be 240g. So 30gx plus 80g is 240g. So that's going to be equal to 160g, and x is going to be equal to 160g over 30g, or in other words 16 over 3, or in other words 5 1/3 meter. Okay, I don't know what the answer is, so I'm going to check I've got it right. And then I'm going to wonder if you actually needed help with this question or a question before. Okay, right, let's have a look. Page 70. I've got the book here, you see. It was 7D, wasn't it? Question 4 is 5 1/3. So hopefully it was this question, but do let me know if it was the other question you needed a hand with. So just one limitation of this model with respect to the ladder and the wall. Well, the ladder, isn't necessarily going to be a uniform ladder. I suppose you could say that. You could also point out it's made an infinitely thin lamina when it would actually have dimensions. Well, the wall is smooth. Is that really likely? Nothing in reality is perfectly smooth, and therefore that could have friction. There we go. Hope that was useful. Let me know though if this isn't the question you wanted a hand with. It was a little ambiguous, as you can see. But yeah, okay, all the best, Izzy. Keep up the hard work, and yeah, good luck. Bye bye.